Hello students and welcome to another video lecture on logic design. The next topic under number systems is the hexadecimal number system. Although it is more complicated than the octal number system, it has become the most popular means for direct data entry. It is made up of 16 unique symbols. The numbers 0 till 9 plus the alphabets A, B, C, D, E, F. A represents decimal 10, B represents decimal 11, C represents decimal 12, D represents decimal 13 and E represents decimal 14. Finally, F represents decimal 15. That is why the base of the radix of the number system is 16. So, since its base is 16, that is 2 raised to 4 is 16, every 4 bit of binary digits can be used to represent a valid hexadecimal number. In the table, you can clearly see that hex 0 is represented using a 4-bit binary code 0000. Hex 1 is represented using a 4-bit binary code 0001. In the same manner, hex 2 is represented using a 4-bit binary code 0010 and so on. Here are some examples of valid hexadecimal numbers. Here are some examples of invalid hexadecimal numbers. Like the decimal, binary and octal number system, hexadecimal number system is also positional weighted. That is, a value is attached to a symbol depending on its location with respect to the decimal point. Let us understand this with an example. Take the number AB 017.E67. The symbols AB 017 make up the integer part of the hex number. The symbols E67 are the fractional part of the hex number. So, starting from the decimal point and moving left, the first position has a weight 16 raised to 0. The next position has a weight 16 raised to 1. The next position has a weight 16 raised to 2, followed by 16 raised to 3 and 16 raised to 4 is the weight of the last position. So, what you notice here is that all numbers to the left of the decimal point have positive powers of 16 as weights. Now, starting from the decimal point but moving right, the first position will have a weight 16 raised to minus 1, followed by 16 raised to minus 2 and the last number will have the weight 16 raised to minus 3. So, numbers after the decimal point have negative powers of 16 as weights. Therefore, the number can be written as 16 raised to 4 into A plus 16 raised to 3 into B plus 16 raised to 2 into 0 plus 16 raised to 1 into 1 plus 16 raised to 0 into 7 plus 16 raised to minus 1 into E plus 16 raised to minus 2 into 6 plus 16 raised to minus 3 into 7. This evaluates to, notice that A is replaced with the decimal number 10 and B is replaced with the decimal number 11. Similarly, E will be replaced with the decimal number 14. This evaluates to a very large number 700,439.9001 corrected to 4 decimal places. The leftmost digit is called as the MSD or the most significant digit because it has the maximum weight associated with this. In this case, that number is A. The rightmost digit is called as the LSD or the least significant digit. In this case, it is 7 because it has the minimum weight associated with it. In the hexadecimal number system, we also have complements. There are two types, 15's complement and 16's complement. How do you find the 15's complement of a hexadecimal number? Simply subtract each digit of the hexadecimal number from 15. 15 is of course the decimal representation for the hexadecimal equivalent, that is F. How do you find the 16th complement of a hexadecimal number? Find the 15th complement of the hexadecimal number and add 1 to the LST. Let us take an example. A3.62 to the base 16, find its 15th complement and 16th complement. To find its 15th complement, we have to subtract the hexadecimal number from 15. 15 is represented as F in hexadecimal. Subtraction in hexadecimal is done very close to the manner in which we do decimal subtraction. So, if we have F minus 2, this means 15 minus 2, which is equal to 13. But 13 in hexadecimal is written as D. In the same way, you can subtract the rest to get the answer as 5C.BD. How do you find the 15th complement of this 16th complement of the same number? Simply add 1 to the LST of the 15th complement. You get the answer as 5C.BE. And that's it for now. A few things to remember: that every number system will have a base or a radix, number of the symbols used to represent any valid number. The base or radix of your hexadecimal number system is 16. It's a positional weighted system. Digits before the decimal point have weights as positive powers of 16, and digits after the decimal point have weights as negative powers of 16. There are two types of complements in the hexadecimal number system: 15th complement and 16th complement. There will be a follow-up video on counting in hexadecimal and hexadecimal arithmetic.